So this is our project on temporal and category-based price similarity network analysis using Pakistan's CPI data. So in this project, we explored how cities in Pakistan are economically connected based on their prices. So we analyzed seven major CPI categories over 2 years, where we used cosine similarity, network analysis, and multi-criteria weighting to compare the cities and understand their relationships. This approach helps us to see which cities are more similar or different in terms of price behavior by providing useful insights for the consumers, businesses, and policymakers.
Okay, so the way we started our project was that first we had to take some data uh, from Pakistan government's websites for their CPI index data. So when we got that data, the data was it was a very long list of items, and they weren't really actually specified into some categories. We were only given products and their prices and their cities. So what we did with that was at first we mapped all that data into a bunch of into seven specific categories, including food, staple and grains, meat, poultry and dairy, oils, condiments and sweeteners, and other categories of the same in the same manner. So for that, first we had to map this data into our categories. So we made the categories and we made sure that all the ones that we knew about were mapped onto that those categories. And as for the ones that weren't exactly mapped into the categories, what we did was we put some keywords into our code, and whenever our code came across those keywords, the code mapped those products into the specific categories that they belong to, as can be seen in the mapping part for Python code. After that, we had to work with this data mathematically. So for that, firstly, we had to understand how to construct vectors for these products. So we used the equation that is on the screen right now, and we took the average prices of those products and we summed them up and divided them by the data that we had. After that, as I said, once we had all the data, all the missing data that we had was unmapped. The data that was unmapped was to be discarded so that it does not interfere with our calculations. So once we had all the data normalized and ready for calculation in our matrices as vectors, what we did was we made cosine similarity matrices for each city. The way these was calculated was that we used the equation for cosine similarity that is well known. And once we had the cosine similarity for product for each city, we used that matrix to generate heat maps that showed how similar certain cities were in a certain category, as can be seen right now for non-food essentials. This heat map shows how similar they are, and the values for that can range between 0 to 1, or they can also go to 0 to -1, but we used absolute value to make sure that it goes from 0 to 1. So as can be seen, the cosine similarities for each city with themselves is 1, and other than that, any similarities can be seen according to this key on the right. After that, what we did was we had to generate graphs based on some certain threshold. So the threshold that we had in our code was to be decided over here, where we put our threshold for a certain calculation, and we calculate the threshold based matrices. So what threshold means is that the cosine similarity for each for two cities is calculated, and if it is greater than or equal to that threshold, only then we can generate edges between those cities on a graph. So if we can see the graph for 0.6 threshold here, these are very dense because 0.6 is not a very strict threshold, and in these graphs, as can be seen, there's a hub here, and there's an interconnected series of nodes, and only the cities that are very different, which means that they're less than 0.6 on the cosine similarity, they get to be disconnected from the graph, as can be seen for Banu in the category non-food essentials. The same thing was repeated with medium thresholds, which was 0.7. Although here for non-food essentials, the difference is not very drastic, but it still has a less dense network as compared to the 0.6 one. And a better example of this can be seen in the 0.8 threshold version, which shows that the hub has now been broken, and these nodes are these are disconnected For example, Islamabad and Rawalpindi are connected to each other, but they're more disconnected from the rest of the graph because their similarity with the other cities is not greater than 0.8. Moving on, we have results and analysis, and Huda would like to present that.
Okay, so for each category, we compared networks across the 2 years using the temporal relations. This relation is reflexive, antisymmetric, and transitive, forming a partial order visualized through the Hayes diagram. So in our data set, very few edge inclusion relations held over time, leading to sparse diagram. This indicates that similarity relationship between the cities existed, but it changed, but did not form a strict temporal hierarchy. Okay, then we computed the four main centrality measures, which were degree, closeness, betweenness, and eigenvector centrality for every graph. So to rank these cities, we aggregated these measures using three weighing schemes. The first one was equal weighting, then correlation-based weighting, and entropy-based weighting. So in equal weighting, it treats all the metrics uniformly. The correlation-based weighting, it reduces the weights for redundant metrics based on the intercorrelations, and entropy-based weighting, it assigns the higher weights to metrics with greater variability and informational value. This allowed us to compute both per category scores and an overall similarity influence score for each of the city. Talking about the results and insights, as shown in our bar chart, it shows how cities' ranking shifts across weighing schemes. Equal weighing favors cities with balanced performance across metrics. Correlation weighing exaggerates differences, revealing clearer top five rankings. And entropy weighting highlights the categories and centrality metrics with high variability, sometimes changing the top ranked cities entirely. As the difference is very obvious in Sakhar and Peshawar, the entropy weighting for Peshawar is less than Sakhar as compared to the equal weighted and correlated weighted where Peshawar is always above Sakhar. Over to Hadia for conclusion.
Okay, to summarize, our CPI similarity network analysis shows how cities relate economically across categories and over time. All the calculations and visualizations were done in Python with Matplot library used to generate the clear graphs and heat maps. Other than that, different weighing methods highlight various aspects of city connections, emphasizing the value of multi-criteria approach. And the dataset for that is accessible through a Google Drive link, making the workflow fully transparent and reproducible. So, thank you for watching.